All right. Welcome. So the goal for today's learning targets is still to continue to just put things together. We've learned everything we need to learn, but we still just need to practice these skills and make sure we can tell the difference between the forms and when we're doing what. So our goal for today is to identify the best method to use to graph a quadratic equation and actually graph it. So last week we finished up with looking at solving and finding the vertex in each of those forms. Today we're going to say, okay, well, now that we can find these things, let's actually go ahead and graph them. So we're looking to graph from all forms. We've learned to graph in factored form, vertex form, and standard form. We're going to practice each of these skills today. So first thing you need to be able to do is, okay, what form am I given? What do I need to find? And then finding and graphing it. So we're going to look at some different examples today. I would highly suggest copying these down into your notes, because if you took notes from last week and you took notes from today, that's really a great generalization, a great overview of everything we've done in this unit and everything you're going to be tested on here soon. In your notes, I would highly suggest writing this down. If I'm still talking and you still haven't written everything down, or if I'm done talking and you still haven't written everything down, I would highly suggest pausing the video to make sure you get this copied down into your notes before moving on. So what do you need to graph in each form? Remember, we have factored form, vertex form, and standard form. If you're given an equation in factored form, you need to find the x-intercepts, which is readily available from the equation, and the vertex. Using that and the general shape of a parabola, you're able to graph. If you're given vertex form, find the vertex. That's what's easily available from the graph or from the equation. And then this is where it gets a little bit tricky. We have to find another point, select another point by selecting an x value and plugging it into the equation and mirroring it over the axis of symmetry. And then standard form, we use the y-intercept, which is what's readily available from standard form, and then we find the vertex and we use that to graph. So we're going to go ahead and look at these different forms and actually going about the process of graphing these. So this is the points that you need to find in order to graph from each of these forms. So before you can graph any equation, the first thing you need to think is, what form is this in? Because once I figure out what form it's in, then I can figure out what do I need to find before I can actually graph. So in order to graph this equation, we need to know what form it's in. So go ahead and select, what form is this in? Factored form, vertex form, or standard form? Hopefully you selected vertex form. This is vertex form. And from vertex form, we're easily able to find the vertex. So what is the vertex? So in order to graph, we need the vertex. So go ahead and tell me from this equation, what is the vertex? Hopefully you told me that the vertex was 2, 6, because it is. Our vertex comes from these two values, and we want to think opposite, same. Opposite of -2 is +2, same as 6 is 6. So we're going to use 2, 6 as one of the points on our graph. All right, so let's go ahead and proceed graphing this equation. So we just said that our vertex is at 2, 6. So let's go ahead and plot that. So what I would suggest is, I have a graph here. I would suggest making a nice little graph, doing some tick marks, so that you could go ahead and graph 2, 6. Let me go ahead and erase that. Too far. Okay, so here I would plot my point at 2, 6. And obviously, that's not enough. I need to have at least 2 other points on this graph. One thing that I can note here, actually a few things, is that my axis of symmetry goes through my vertex. So this is the middle of my graph. I can also hopefully recognize that because there is a negative out in front here, that this graph is going to have a maximum and it's going to open down. So this graph is going to go down like this. I don't know exactly where yet, but it is going to go down. So obviously, like I said, that 1 point's not enough. We need to find another, and then we can mirror it on the other side of the axis of symmetry. So knowing the vertex, I could pick some points. So if I know that my vertex is at 2, 6, I can then pick another x value. I could either pick 1 or I could pick 3. Could I pick 0 or 4? Absolutely. But the closer I am to the vertex, the smaller the numbers are going to be to work with. So I would suggest picking close to the vertex within a few. So pick which one you want. If you want to plug in 1 or plug in 3. Say I want to plug in x equals 3. If x is 3, I need to figure out what is y. Well, I have my equation. Y equals -3. And if I'm going to say x is 3, I'm just going to plug that in. So I chose the x value 3, and I just plugged it in. And it's going to output the y value. So I'm going to do parentheses first, order of operations. 3 minus 2 is 1. I'm going to do exponent next. 1 squared is 1. Then I'm going to do multiplication next. -3 times 1 is -3. And -3 plus 6 is 3. So this point would be at 3, 3. Okay, I can plot that. So if it's at 1, 2, 3, up 1, 2, 3, what do I know? If it's on one side, that means this has to be 1, 3. They have to be the same. If it's 1 away on the right, it's got to be 1 away on the left. And I said that my parabola should open down like this. And look, it does. It's got that U shape. It should have that little bit of bend there. We don't want to have lines because it's not going down at a consistent rate. We do want to have that U-shaped parabola look there. So that is how we would graph something in vertex form. We would find the vertex from the equation. Then we would find a point to either the left or right and plug it in and then mirror it on the other side. So that is vertex form. Vertex form was one that we struggled with the most. So hopefully after seeing this and looking back in our notes from graphing in vertex form, it's starting to come together a little bit. So whenever we graph, first thing we have to say is, okay, what form are we given? So given y equals 1/5 x squared plus 2x plus 6, tell me, what form do we have? Is it factored form, vertex form, or standard form? Hopefully you told me that this is standard form. We have ax squared plus bx plus c. So that leads us right to standard form. So looking back at our notes, from standard form, we need the vertex and the y-intercept. So go ahead in the text box, tell me, what is the y-intercept? You should have hopefully told me that the y-intercept is 0, 6 because it comes from our c value. And c, or a constant in this case, is 6. So 0, 6 is going to be one of the points we're going to graph. And what about the vertex? So in order to graph, we need the vertex. So given this equation, see if you can figure out what the vertex is. And then go ahead and make your guess and then check by moving on in the video. All right, so look in here. In order to find the vertex, we need both A and B. C was for the y-intercept. And remember, our vertex is a coordinate. And x is negative b over 2a. So hopefully we got negative 2 over 2 times 1/5. We got to do a little bit of work here. So we would have negative 2 over, if we multiply these, 2/5. Well, we're dividing. So remember, when you divide by a fraction, you have to think same, change, flip. So we kept the first number the same, we changed division to multiplication, and we flipped the fraction. We're multiplying by the reciprocal. Now we're multiplying fractions. We get negative 10 divided by 2, which is negative 5. So our x-coordinate is negative 5. Well, y then is just plugging in negative 5, so I would have 1/5 times negative 5 squared plus 2 times negative 5 plus 6. Well, exponent, I get negative 5 squared is going to be positive 25 because 2 negatives make a positive. 2 times negative 5 is negative 10. This is 1 times 25, which is 25, divided by 5. So 25 divided by 5 is 5. 5 minus 10 plus 6. 5 minus 10 is negative 5. Negative 5 plus 6 is 1. So hopefully you got the vertex to be negative 5, 1. If not, pause and make sure you have this written down. So we said that our y-intercept was at 0, 6. And our vertex was at negative 5, 1. So looking at this, it is positive, so our graph should open up. Let's plot these things that we know. So we know that the y-intercept is at 0, 6. And we know the vertex is at negative 5, 1. Well, think about what else we know. We also know that the axis of symmetry goes through our vertex. And points on the right are the same as on the left, and vice versa. So this point here is 1, 2, 3, 4, 5 to the right. So 1, 2, 3, 4, 5 to the left is the same point. This graph is a parabola and it opens up. So we took our y-intercept, which comes from the equation, and our vertex that we solved for, and we graphed by finding that third point using the axis of symmetry. And lastly, in order to graph, we need to know what form it is. What form is y equals 1/3, x plus 2, x minus 4? You should have said that this is factored form. And let's think about, what do we know about factored form? It tells us the zeros, which is our x-intercepts. So we're going to use our x-intercepts and, of course, the vertex to go ahead and graph. So what are our x-intercepts? So given this equation, go ahead and find the x-intercepts, and then go ahead and type that in so that I can see what you got, and then we can move on for you to check your answers. All right, so hopefully we got that x equals negative 2 and x equals 4, because we would set this equation equal to 0, Set our factors then equal to 0 because of the zero product property. And solve. So we would do our inverse operations to get x equals -2 and add over 4 to get x equals 4. So these would be our two x-intercepts. We would have a point at -2, 0 and 4, 0, and we would plot those. But we also have to use these to help us find the vertex. So let's see if we can remember how to do that. So to find the vertex, we know that our x-intercepts are at -2 and 4. Those are 2 points, so we could actually go ahead and plot those. We could say, oh, okay, our x-intercepts are at -2 and 4. 1, 2, 3, 4. Well, we know the axis of symmetry goes through the vertex, which is directly in the middle of these points. So our vertex, the x value is going to be halfway between -2 and 4. So we cut it in half. So 4 minus 2 is 2. 2 divided by 2 is 1. So our vertex is going to be at 1 something. What is that something? Well, now that we know what x is, we can plug that into the equation to find y. So we have 1/3 times 1 plus 2 times 1 minus 4. Parentheses first, we get 1/3 times 1 plus 2 is 3 times 1 minus 4, which is -3. We could go in order, or we could do 3 times -3 first. But if we did 1/3 of 3, 3 divided by 3 is 1, and 1 times -3 is -3. So our vertex is at 1, -3. So 1, -3, and it's a positive 1/3, so our graph should open up, and that would be our parabola. We have our vertex, we have our two x-intercepts. We have 3 points on this graph to sketch our general shape through. All right, so now we've seen a recap of graphing from factored form, vertex form, and standard form. You have another example. You should also have notes from these sections going over multiple examples. So in order to practice this, what I would like is for you to complete the following assignment in Khan Academy at a 75% or better. There's also a video assigned that you can go and view as well if you need a little bit of extra support. The assignment is graph parabolas in all forms. So you're going to be given a quadratic equation in any of the 3 forms. You need to decide what form it's given to you in, what you need to find it, and then plot those points to graph. If you finish that up, please make sure that any other missing assignments from this unit are completed in Khan Academy, as we are going to begin reviewing essentially. Test is coming up, so any missing assignments need to be done. So let's continue to work on those now that we've started to recap these ideas. So Wednesday, we're going to review. Thursday, Friday, we're going to quiz. And then next week is review and test. So we're coming to the end here. We really need to make sure we have a good grasp on this. So this is a really good review here. The graph, the parabolas in all forms. So then Wednesday we'll review solving in all forms, graphing in all forms, and applications as well. So if you have any questions, please feel free to email me. Otherwise, you are looking to get in Khan Academy and complete this assignment.